The Royal Meteorological Institute is established in Dorbs since 1956. Every day at the Magnetic Observatory, the magnetic field is measured with the precision to the nearest nanotesia. The data taken here are crucial for the research, navigation, and telecommunications. The magnetic gradient of this place is at the most stable and smallest level possible. The materials used here have been chosen to not influence the Earth field. This is the challenge the AUTODIF also took up. It was elaborated here at the Geophysics Center of Dorbs. Until now, the magnetic field was measured in 3 steps. The field amplitude is measured automatically by a proton magnetometer. Variometers observe the variations of vectorial components. Finally, absolute orientation measurement and manual vectorial measurements are taken with a non-magnetic theodolite. This is the part of the procedure the AUTODIF can make on its own. Indeed, the AUTODIF measures magnetic fields automatically while keeping a magnetic cleanliness. The results reached attest the innovation of the AUTODIF. We obtained an efficient, precise, and autonomous prototype. The classical method of measure with the theodolite also requires a perfect magnetic cleanliness from the person who takes them. Both of the methods measure the declination and inclination angles of the field to the nearest second of arc, compared with the true north and horizontal plane. The 2 methods take 4 declination measurements and 4 inclination measurements, and the measurements retained are the average of each. But the AUTODIF and its laser make it automatically, which reduces the error risk compared to the manual method. It guarantees precision where the human eye can fail and is created in a way to correct by itself its eventual errors. The electronic level is very sensitive and stable despite the movements of the AUTODIF. Moreover, the leveling errors will be taken in account and corrected in calculations. The motors are non-magnetic. They position the axis with a precision to the nearest thousandth of a degree. The non-magnetic encoder system also connect challenge and innovation. The encoders read the angles to the nearest arc second. Specific encoders adapted for the AUTODIF have also been elaborated here. With the resolution and repeatability of the motor encoder system, the laser is reflected in a distant mirror. The encoder measures the small displacement of the spot in arc seconds. Then, the AUTODIF makes a complete cycle and the spot comes back at the exact same place. Finally, the unique interface allows to read and interpret the data. The measurements of the laser, the 4 declined and inclined measurements, the final result calculated, etc. To sum up, the AUTODIF is easy to use and ensures regular measurements even in inaccessible places. The results are similar to those gained by the manual method. It reaches its performance without the human hand. Its autonomy guarantees more homogeneous measures. In the long run, the AUTODIF will enable the development of full automatic observatories, and in turn, a wider knowledge of our Earth globe.